Hello class, and welcome to a very quick lecture, feel free to pause if I'm going too fast, on complex circuits, specifically on how to find the equivalent resistance of it. This should be on page 123 of your interactive notebook. Moving right along, a complex circuit. This is defined as something that has a parallel section and a series section, or lots of parallel in one series, or any combination you can possibly imagine. For instance, here's a really basic complex circuit because it has a bit in parallel and then it has a bit in series. The yellow bit is in parallel and the yellow and this other resistor are in series with each other. That's what the blue shows. So how would you find the equivalent resistance of this? Well, how I would do it is first I'd solve for that parallel section. And I'd say, all right, that parallel section has an equivalent resistance of something. And then I'd pretend it's one resistor. And then I'd say, oh, hey, look, now I got two resistors in series with each other. I know what to do there. I just add the resistances up, giving me a resistance of something. Effectively, you're going to take your complex circuit and turn it into a simple circuit. Now, for this circuit, that's going to take us 2 steps. Step 1 is draw the circuit as it exists, and then draw it with the parallel section as one resistor. Okay, we now need to find the resistance of that one resistor. All right, so I'm going to do 1 over 30 plus 1 over 40 equals number. 1 over that gives me the equivalent resistance of the parallel bit, which happens to be 17.1 ohms. All right, step 2. I'm going to draw the series bit turning into a simple bit. And to find that REQ, well, I just add up the resistances, and I get 37.1 ohms. Done. To find the equivalent resistance of a complex circuit, you have to draw and label the circuit as it really exists. Then figure out the bit that you can simplify. Just focus on that. Find the equivalent resistance for just that piece, and then redraw the circuit with that piece as one resistor. Then you keep going, you keep doing this, taking one piece and simplifying it, taking one piece and simplifying it, until you have a simple circuit, one battery and one resistor. Here's how I would draw it in my notes. Here's how I would do it if I were doing this problem. I draw the first picture, I draw the second picture, I draw the third picture. All right, now please try it with this one. The same resistors, but now they're wired a little differently. I want you to hit pause, and when you have an answer, hit play again. Pause. Play. All right, so here's how I would do it. Step 1, I realize that, hey, 20 and 30, they're in series. I can simplify that together. That gives me 50. So now I pretend that this is my circuit. And then I say, oh, hey, 50 and 40 in parallel. I can simplify that. Gives me that. Final answer. Pretty straightforward. It looks like that altogether. Now, I want you to attempt this one and bring the answer to class. If you'd like a hint, I see a section there that can be simplified. I see a section here that can be simplified. Then I see a section here that can be simplified. And then a section here that can be simplified. If that didn't help, well, ignore it. All right, good luck.